Hey everyone, welcome to our senior secondary mathematics. In this video, we're going to take a look at a very important topic in mathematics. Actually, it's simple and it's interesting, and the topic is algebra. So, the way this first video is organized is it will start with the basic processes of algebra, which are some of the skills that are expected of you. Of course, when you're going grade 10, they don't teach these skills because they assume that you still remember them. But here, we're going to just do a refresher to remind you of the basic processes so that you don't have difficulties in understanding the advanced processes or the process that you are supposed to learn in senior secondary. Of course, for those who are in my class, you'll be tested and I have to make sure that you have gained these skills. So, the first part of this video, of course, will start with the same, like I said, the basic process of algebra. Then after that, we'll start the actual things that you're supposed to be learning. And of course, that's where I'll introduce the topic map so that you have got a clear understanding of how the whole topic is organized. Then from there, we will start the actual things. So we're going to start with basic processes, and we'll first take a look at adding and subtracting algebraic terms. But before we can actually take a look at this, I'll introduce some basic terms or terminology or some concepts that that constitute the algebraic language. So algebra is something that we've been doing for a long time. If you can remember this kind of mathematics as far back as grade 6, grade 5, 2 plus box equals 5. The job was to know what number can be put here. Of course, for those who can still remember, it's 3 because 2 plus 3 is equal to 5, meaning that this side is now equal to this side if we put 3 here. So how is algebra coming in here? So as the grades advance, as you reach grade 8, the box was replaced by X. Of course, I think starting from grade 7, that's where this change started. The box was replaced by X. So algebra, that's where it started from. So algebra is where that which we don't know, the unknown, is represented by a letter. A letter can be any letter. It can be X, it can be Y, it can be B, it can be W, it can be any letter. So just know that whenever you see a letter in mathematics, it means it can represent any number which we don't know. So this expression in algebra is written like this: 2 plus X is equal to 5. So, of course, you can just substitute X with 3 because you know that X is 3. But now there are techniques that have been developed on how to solve such kind of questions, because some questions are complicated. You can't just tell what X is just by looking. So we're going to start with the basic processes so that we know how to work with letters. For us to go into adding and subtracting and other operations that have to do with algebra, there is one important thing we need to know, and that is something written like this. So if a letter and a number like this, without a plus or minus here, they are just like this, where they appear to be connected. This is called a term or an algebraic term. It is made up of two parts, the number part and the letter part. So any term is made up of two parts, the number part and the letter part. So the number part is called the coefficient and the letter part is called a variable. I won't explain where this coefficient comes from, but I'll just explain where the word variable comes from. So variable is another word for changeable, meaning that this can change. For example, here is 2 plus box is equal to 5, and the value of this X is 3. But what if there was 1 here? If there was 1 here, then it could have been 1 plus box equal to 5, and our box could have been 4, meaning that 1 plus 4 is equal to 5, which means the number that X represents is 4. So X changes. it can represent 2 today, it will represent something else tomorrow. That's why it's called a variable or changeable. So an algebraic term is made of these two parts, the coefficient and the variable. I haven't explained where they got the word coefficient from, because I think you might need to, or maybe it might be a bit advanced. But if you are interested, coefficient is made up of two words, co and efficient. Efficient means it has to do with power. So if you say coefficient, it means this number here shows you how big the term is, but it's not important. This second information is not important. What is important is the variable or the changeable. So there's another fancy way of writing a term. There's only one coefficient that has got where this secret that I'm about to reveal applies, and it's something like this. If you see this, is this a term? So you can say there's only a letter, there is no number here. So you can adjudge that it's not a term, but it is a term. So mathematics, again, they have agreed that if the coefficient is 1, it's better don't write the 1, so that at least we don't waste time writing things. So whenever you see a letter, just know that there's an invisible 1 in front of it. So this is some of those things that mathematicians agree. Just like when we were learning indices, there was like 2 to the power 1. It is usually written as 2. The 1 is never shown. Even when we're doing integers, we said positive numbers don't show the sign. Those are some of the conversions that the scientific or the mathematics community have come up with. So x and 1x is one and the same thing. When you see this, just remember that there is an invisible 1 in front of x. So let's start adding and subtracting algebraic terms. Actually, to add and subtract algebraic terms, you need to know about what are called like terms. So like terms are terms like these. Like terms are terms with the same variables. The coefficients can be different, but the variables should be the same. Our variable here is y, and our variable here is y. So they have the same variable, and these two are like terms. Another example of like terms are these two, 3abc minus 2abc. So a, b, c are variables, and here we have a, b, c as variables. The coefficients are different, but the variables are the same. So these are like terms. We also have got these 6x and x. So what's the variable here? X. And what's the variable here? It's also x. The coefficient, of course, is the invisible 1. So these are like terms because the variables are the same. The same applies to these. 4w power 3 minus 1000 w power 3. So the coefficient here is 4 and here is minus 1000. But the variables are the same, w3 and w3. Note that if we had another term like 2w power 3, 2w power 3, or I mean 2w, just 2w. So 2w is not is not a like term to 4w power 3. So what I'm trying to emphasize here is if they are like terms, then even the power should be the same. W power 3 is a like term to w power 3, not w power 2, not w power 10, not w power 100. Examples of terms which are not like terms are these, 3x and 4y. So here the coefficients are different and the variables are different, so these are not like terms. Another last example is this, 3cxy and 3bxy. So the coefficients are same, but the variables are different. This is cxy and this is bxy. So they are not the same, unless they are c here, but there is b. So these are not like terms. So to add algebraic terms, here is what you should always remember. Algebraic terms can add or subtract only if they are like terms. So if they're not like terms, then algebraic terms cannot add or subtract. So to add or subtract like terms, you just add or subtract the coefficients. So to add or subtract algebraic terms or like terms, which of course can add and subtract, you just add or subtract the coefficients. For example, 2x plus 3x. So you first you identify if they are like terms or not. So these are like terms. They both have the same variables. So just add the coefficients. 2 plus 3, which is going to give us 5, and our answer is 5x. So 2 plus 3, 5, and we have the variable at the end. Other example is 2x minus 3x. So, of course, this is 2 minus 3. We call integers sign of the larger number, difference of the two. The larger number is 3, whose sign is negative. So, the answer is 2 minus 3 is negative 1. Remember, we don't show the 1, it's invisible. So, it's just negative x. The other one is, of course, 2x plus 3y. So, 2x plus 3y, it's, of course, can we add these? So if we look here, this is a variable x and this is a variable y. These are different variables. We cannot add them. So just because these are not like terms, they have different variables. So addition or subtraction cannot be applied. So you just leave them like this. Let's get a more complicated example. So I've got 2x plus 4y plus 4x minus y plus z. How do we add this expression? By the way, if terms are combined, if there are more than one term separated by plus and minus, we call it an algebraic expression. So this is an algebraic expression. So this is a term, 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 separated by pluses and minuses. So how do we handle this? So the first thing that you do is you combine like terms. To combine like terms is you bring like terms together. We have got 2x here. Is there a like term to 2x? Look, 4y is not a like term to 2x, so we skip it. 4x is a like term to 2x. So it's better we write 4x here. Then this 4y, we take it somewhere else where there is y. So when we do what I'm saying, we're going to have something like this. So we have 2x here, then 4x, it's here. And here's one thing you should keep in mind. This term here is not just 4x, it's positive 4x. So when you are bringing it here, where you want if you want to put it close to 2x, you have to carry together with the sign. So positive 4x is what will come here, positive 4x. Then we are done with those terms which are like terms with x. We have collected 2x and 4x, and positive 4x, I mean, which is here 2x positive 4x. Then we go to positive y. So I've just written positive 4y here. Then we look for its like terms. So scanning through the expression here, we have got minus y here. So we write it here, minus y. So positive 4y minus y. Then we remain with z, which doesn't have a friend or a family, doesn't have a like term. Once we do this, we can start adding the like terms. So 2x plus 4x is going to be 6x. 4y minus y is going to be 3y, and we can just bring z here. So here, we cannot do anything because these are not like terms, and this is how this question is handled. Let's take a look at another. 3x squared plus 4abx minus x squared minus ab plus 3abc plus ab. So the job is to identify which ones are like terms. So if we start here, we'll start with 3x squared. Which term is a like term to 3x squared? So this is not minus x squared. We look at the variables. This is x squared and this is x squared. So these are like terms. Again, people prepare questions can be tricky. So they can just put x here. So if it's x and this is x squared, they are not like terms. Okay, they should have the same power if they are like terms. So 3x squared minus x squared. So these are like terms because this is x squared and this is x squared. So we will put these together. Then 4abc. Which term is a like term to 4abc? So scan through the system. This one, of course, is not. Minus ab. Is this a like term to this? This is abc and this is ab. So they are not like terms unless they are c here. So this is not a like term to this. So we skip it. Then we go to this one, plus 3abc. This is also ABC. So these are like terms, 4ABC and 3ABC. We're going to group them together. Then we have grouped this, and this. We remain with this one. This is negative AB, and this is positive AB. So they have got the same coefficients, the same variables, which are AB and AB. The coefficients don't matter when we are looking at like terms. Therefore, these two are going to be grouped together. So at the end of the day, we're going to have this 3x squared minus x squared plus 4abc plus 3abc minus ab plus ab. So now we can start adding and subtracting. So 3x squared minus x squared is going to give us 2x squared. Positive 4abc positive 3abc is going to give us positive 7abc. Negative ab plus ab is going to give us 0. Why? Because when adding and subtracting, of course, we deal with the coefficients. So there is 1 here and there is 1 here. So negative 1 plus 1 is 0. So we're going to have 3x squared minus x squared, which is just 2x squared, and 4abc plus 3abc is going to be 7abc. Let's take a look at the multiplication and division. We'll start with multiplication. So algebraic terms can be multiplied regardless of being like terms or not. So multiplication is not selective. It can multiply. Doesn't matter whether terms are like terms or not. So look at first case where we deal with a number and a variable. So if we have 2 times y, the answer is 2y. To multiply these two, you just combine them, you remove the multiplication symbol. So 2 times y is 2y. This should always remind you when you see something like this, 2y, 3a, where a number and the letter are combined, just know that these two have been multiplied. There is multiplication somewhere. Another way in which you can look at this is okay, I want to go to the other way. It just might confuse you. So this is just the easiest way you can look at it. 2 times y, you just combine them, you have 2y. 3 times v, you combine them, you have 3v. We have 2 times a times b times c times d. So you just combine everything, 2a, b, c, d. That's multiplication, 2a, b, c, d. Then there is another situation where we have like terms, where we're multiplying like terms. So if we have 2y times 3y, these are like terms. So for this, you can also combine them like 2y, 3y. But the best way to present them is you can multiply the number parts and also the letters. And if you multiply the number parts, positive 2 times positive 3 or 2 times 3 is going to be 6. And y times y, if you recall indices, y times y, it's y squared. So just multiply the numbers and the letters like this, 2 times 3 and y times y, which is going to give you 2 times 3, 6, and y times y, y squared. So I've done it like this just for illustration, but for those who can just do the multiplication in their heads, you can skip this part. You can just equate this to 6y squared. 2 times 3, 6, and y times y, y squared. So it's going to be 6y squared. Let's go to division. When dividing algebraic terms, divide the numbers and letters separately. So when dividing algebraic terms, divide the numbers and letters separately. So let's have this example, 4xy divided by 2yz. So the other way in which we write division is, of course, to use the over symbol, like 4xy over 2yz, like this, 4xy over 2yz. So you can divide the numbers, then you go to the letters. So 4 divided by 2 is going to be 2. Or the other way you can do it, you can just cancel. How many 2's are in here? 1. How many 2's are in here? 2. So you once you cancel, you just write your 2 here and your 1 here. Then you go to the letters. The letters also, the way to divide them is to cancel. So you ask yourself, do we have y on top? Yes. Okay, so we say how many, if we cancel, or how many y's are in y? 1. And how many y's are in y? 1. And again, we go to z. Do we have z on top? No, we don't have. So we are done. So what I've done is I've divided the numbers, 2 in here, 1, 2 in 4, 2. Then I've gone to the letters, asked myself, do we have y on top? Yes, we have, so we can cancel. Y here 1, y here 1, but we don't have z, so we leave it. It gets itself involved if there's something on top which is not a like term, but which are if it is just present on top in any form. So z is not present on top, so it won't get involved. Even the x not present on bottom, so it won't get involved. So just a summary: numbers first, 2 here 1, 2 into 4 2. So I've remained with 1 and 2 on top. Then we'll go to y here 1, y here 1. So we'll have something like this. So on top I remained with 2 as a number, then and the x, the y was 1. So of course 1 is just it can be it can be more. The 1 here has multiplied with everything. 1 times everything is everything. 1 times 4x is 1 times 2x is 2x. I might be confusing you, so let me just say what I've just said. So I've said 2 here 1, 2 here 2. So this is our 2. X doesn't get involved, so it remains. Then we did y here 1, y here 1. So it's supposed to be 2x1, but 2x1 is just the same as 2 times x times 1, which is just 2x, because anything multiplied by 1, it's anything. Then on the bottom here, we remained with 1, y would remain with 1, which means at the bottom we have 1 times 1 times z. So 1 and 1, 1 times 1 times z is just z, which is 2x over z. I was supposed to show this in details, but I was assuming that you might have ideas of what I'm saying. The other one is 15xy squared v power 10 divided by 10v cubed y power 6 z. So v power 3 is v cubed. So again, we'll bring the over sign here and we'll do the same as we did before. So we'll start with 15 and 10. How do we divide 15 and 10? So of course, we can't directly divide 15 and 10. So we can just look for a highest common factor, or a number that goes into 10 and 15, so that we reduce this into the lowest terms. So we ask ourselves, one number goes into 10 and 15? 5. So 5 into 10 is 2. 5 into 15 is 3. Then we go to the letters. V. Do we have V on top? Yes. So here is v power 3. Here is v power 10. So say we divide here v power 3. All the we have 1, and here v power 3. So the way you do it, it's v10 divided by v3, it's v power 7. If you can remember, in this is v10 divided by v3, it means division, remember, it's like it's minus. So v10 divided by v3, it's like v10 minus v3. So even from here, v10 minus v3. Okay, I've just I've made the mistake here there. Let me just explain clearly. So I'll start again. So with the numbers, we'll look for a number that goes into 10 and 15, so that we write them in their simplest form. So the highest common, or in short, the highest common fact. So what's the highest common factor of 10 and 15? It's 5. So 5 into 10, 2. 5 into 15, 3. There's no any number that goes into 2 and 3. So we leave it here. Then we go to the letters. We can start with V. So V10, V3. So we can cancel here. V3 here will remain with 1, and V3 here will remain with V7. So what have I done cancelling? So V10 divided by V3. V10 divided by V3. If we use the division law of indices, it means the powers can subtract. So V10 divided by V3, it means V power 10 minus 3, which is V7. The other way in which we used to do was, we could just expand this. We could just write it as V times V times V, and this one, V times V times V times V times V times V 10 times. Then we could just cancel the V's. Here the 3 V's will go, and if we cancel the 3 V's, we'll remain with the 7 V's. But it depends on which one you like. Then we'll go to the next one, y power 6, and on top there is y power 2. So again, we can use the division law of indices. Y power 2 divided by y power 6 is going to be y power 2 minus 6. The powers are going to subtract. So 2 minus 6 is negative 4. And if you remember, y power negative 4 can be written as 1 over y power 4. So that's why we have y power 4 here. But of course, that might be confusing. So let's use the idea of cancelling. So I've got y2 here. So you can just, if we cancel here, we remain with 1. And from y6, if we remove y2, we remain with the y4. So this is this. Hope that one was simpler. We go to z. Do we have z on top? We don't have z, so it will remain. Even on top, we have x, which we don't have x on the bottom, so it will remain. So that's how division is done. I don't know if this was an easy explanation, but I know there is an easier explanation. But if, of course, you didn't get it, you can get in touch with me so that I develop something simple you can get. But in summary, for the numbers, look for the number, the biggest number that goes into 10 and 15 without a remainder, which was 5 in this case. 5 divided by 2, by 10, it was 2. 5 divided by 15, it was 3. Then we go to we went to the letters. We said V3 and V10. So we said V3 here will remain with 1. V3 from V10 will remain with V7. So that's how to divide. To divide is like you just work with the powers. 10 minus 3, just like that. Even we went to y power 2 and y power 6. So this is smaller and this is big. So y2 here will go remain with 1, and y6 here will remain, if we remove 2, we remain with y power 4, which is this. And of course, the z and the x don't get involved, so they will remain. So it ends here. So this marks the end of the basic processes of algebra. Of course, there are some more basic processes which we're going to take a look in the next part. So the next part is taken from an old video. So it's going to restart. I'm going to introduce the concept map and everything. Then we continue. So actually, I had forgotten one concept. Before I can go to the next part, there is one important concept also called substitution. So sometimes it is required to work with letters. Then at the end of the day, we are told to substitute, to replace the letters with their numbers. Sometimes we can be told that this letter represents this number. So it will be required to work with letters. Then at the end of the day, we're supposed to put back the original numbers. So I will learn this through an example. Given that w is equal to 4, y is equal to 2, and z is equal to negative 3, evaluate the following. Given that w is 4, so what they are saying is w represents 4, y represents 2, and z represents negative 3. Evaluate the following. So I've got a, which is y plus w, b, which is y minus z, c is y power w, and d is 3y over 2z. So let's start with the first one, y plus w. So the y is 2 and w is 4. So we can just put, where there's y, we'll put 2, and where there's w, we'll put 4. So y plus w is going to be equal to 2 plus 4, which is 6. So this is how to deal with substitution. The other one is y minus z. Y minus z. So y is 2 and z is negative 3. So we just replace here. So be careful. The reason why I created this question was because I want you to be careful in working with integers. So y minus z, remember z is negative 3. So we write like this. So y is 2 minus z is negative 3. Don't assume there is a negative, so it means this negative has been represented. This is negative 3, so you introduce brackets and you put negative 3 inside the brackets. So we have 2 minus 3. So 2 minus 3, we're going to go back to integers. Negative times negative is positive. So we're going to have 2 plus 3, which is equal to 5. Then we have y power w. So again, y is 2. So we just replace y with 2 and w with 4, because w is 4. So 2 power 4, which is 16. 2 times 2 times 2 times 2, it's 16. So this is how to work with substitution. I think now we are done. We can go to the next.